This is lecture 2 from chapter 10, and we're picking up with more practice on balancing equations. So I've got another equation here for us to balance. This one looks pretty gnarly compared to the last equation, and that's because this is an ion compound equation. And it's not just an ionic compound equation, but it's a polyatomic ion equation. So if you look, that's why we've got the parentheses here. These are polyatomic ions. I also made sure that I put the parentheses around every polyatomic ion, whether it had a subscript on the outside or not. So that way you knew that these were polyatomic ions. So I already have written out my list of elements. So if you want to take a second and pause the video and write out your list, you can go ahead and do that. But I'm going to go ahead and start counting up. So calcium on this side, we've just got one calcium. As far as hydrogen goes, remember, if the subscript is on the outside of the parentheses, you have to multiply by everybody on the inside. So we've got 2 out here, so that means we have 2 hydrogens inside. These are the only hydrogens on the reactant side, so 2. Carbon, so we've got 2 carbons here because we've got the subscript, and we've got a carbon in our other compound, so that gives us 3 carbons. And the other one we've got over here in this compound is oxygen. So we've got a 3 and a 2. We have to multiply, so that gets us 6. But we've also got oxygens over in this compound, so that gets us 3 more. So 3 plus 6 is going to give us 9 oxygens. And then we have our last element, which is sodium, and we've got 2 of those. So that gets us all of our reactants. Now we've got our other side. So let's take a look over here. We've got 1 calcium, hydrogen, no subscript, so just 1 hydrogen, carbon, no subscript on either compound, so we've got 2 carbons. Same for the oxygens, no subscripts, so that's a total of 3 plus 3 or 6. And sodium, no subscript on this side, so 1 sodium. So we're going to start off again balancing, and we're going to look, okay, calcium, we're good. That one's balanced. Hydrogen, not balanced. So let's take a look. If we take this compound, that's where it's the bigger. So if we put a 2 in front of this compound, that makes hydrogen 2. So 2. So let's see what that does to the rest of the equation, because that does change the numbers. So it is going to make us have 2 sodiums, so Na2, which actually balances those. Awesome. We get 2 carbons, so that gets us 2 plus 1. That is going to balance out and give us 3 carbons. Ooh, look at that. That balanced that one. And then 2 times 3, that gets us 6, 7, 8, 9. That's going to balance out the oxygens. So it just happened because hydrogen was the first one in the list. By putting that coefficient of 2 in front of the sodium hydrocarbonate, we get our balanced equation. All right, let's try one more. So we're going to combine hydrogen and nitrogen to make this compound, nitrogen trihydroxide, or no, sorry, nitrogen trihydride. There's no oxygen here. So these guys, we're going to balance the same way. So on this side, we've got 2 of our hydrogens and 2 nitrogens. On the other side, we've got 3 hydrogens, and we've got 1 nitrogen. So in this case, it looks like it might be easier to try and balance the nitrogen first. It's up to you, but let's try that. So if we put a 2 in front of the compound over here, that means we have 2 nitrogens on this side. We now have 2 nitrogens on this side. Cool. And we've got 2 times 3. That gets us 6. So then to get our 6 on this side, all we have to do is put a 3 in front of the hydrogen. That gets us 2 times 3. That gets us our 6. All right. So I've given you some other practice equations here. So try these ones out. The answers again are in the notes section. If you would like to go through these, please let me know. I can either post a video or we can go through them during office hours. So I understand that these can be difficult. Also, one of your labs that I'm going to get posted is going to have more equations to balance, so you'll have lots of practice. I will also be posting a website that allows you to do some practice as far as balancing equations, because this one's one of those ones that just takes practice on figuring out which one to put the coefficient in front of and so on. All right, so the next section on chapter 10 is looking at types of reactions, because we can balance the reactions, but these reactions do fall into specific categories. So the first specific category is what we call combustion reactions. And this is actually the first reaction that we've looked at in balancing reactions. Combustion reaction is where you have a hydrocarbon, so any kind of compound that contains hydrogen and carbon. And there is oxygen present. So a combustion reaction requires those 2 elements in order to occur. So it needs a hydrocarbon material and the presence of oxygen. So you can see some examples of hydrocarbons up here. So gasoline, propane, cornstarch, because starch is a hydrocarbon, and sugar, because it's got hydrogen, carbon, and oxygen as its components. So yeah, it'll also occur with the carbohydrates like glucose. That's the starch. Starch is actually made up of glucose molecules because those are hydrocarbons. The reaction usually happens with flame or heat source. There are a few that don't require a flame or heat source, but that's rare. Most of these require some sort of ignition source in order to start the reaction. So think about it like gas cans don't just spontaneously ignite. They need some sort of heat source or flame in order to get them going. And what 2 compounds do they produce? Well, you've seen these reactions. Think about the propane reaction that you saw in the earlier lecture, as well as the methane reaction. Combustion reactions always produce the same 2 compounds. They're always going to produce carbon dioxide and hydrogen, or I'm sorry, water. I almost was going to use the chemical name. So they're always going to produce carbon dioxide and water. That's how you know it's a combustion reaction. If the 2 products are carbon dioxide and water and that's it, and you look on the reactant side and see a hydrocarbon and oxygen, you know you're looking at a combustion reaction. So here's that methane reaction that we saw earlier. Methane plus oxygen gets you carbon dioxide plus water. So the next classification of reaction is what we call combination or synthesis reactions. Combination because you're putting things together. Synthesis because to synthesize means to make. And so this is simply a reaction where you get 2 or more substances combining together to make a single compound. So the reaction that you're looking at here in this equation is the reaction to make rust, like you see on the car. So you've got iron plus oxygen getting you iron oxide. So the combining substances can be just elements, like you see here. So these are, pure elements to make a compound, but they can also be compounds. So we've seen other reactions, and you'll see some of these in labs and examples where it's compounds that are coming together to make one single substance, or it can be a combination. It can be elements and compounds combining together to make one single compound. So we represent this as a general equation. X plus Y gets you XY. So this is how you know it's a combination or synthesis reaction, because you're taking parts, 2 different parts or 3 different parts, and they all combine together into one item on the product side. You won't get multiple parts, you get one product on the product side. Decomposition reactions, these are the opposite of a combination reaction. So you're going to usually require some sort of energy in order to get a decomposition reaction to occur. So you're going to need heat or electricity in order to get these to work. So we've got here mercury oxide. That's the reaction that's actually happening down here in the test tube. So a compound is going to get broken down. That's what a decomposition reaction is. So here you can see we've got a single compound and it's getting broken down. Now what it can get broken down into, it can get broken down into the elements like you see here, mercury and oxygen. But it can also get broken down into simpler compounds. So sometimes you just have something big, like say, trying to think of one off the top of my head, which I can't think of course. But you can have big complex compounds that in a decomposition reaction break into smaller compounds. So they just break into smaller, simpler compounds from that big version. And just like a combination reaction, you can get a combination of elements and simpler compounds from this decomposition reaction. So the simple version of how we represent a decomposition reaction is just the opposite of a combination reaction. So XY is going to result in X plus Y. So this is just the general representation of these equations, but it can be any version of these. So you get a single compound, and then you're going to get multiple things on the other side. So those are 3 major groups of the reactions. There's one other group that we're going to talk about that's a major group of reactions. I'm going to actually start that in our next lecture because it's going to take me a little longer than the couple of minutes I have left in my recording time.